All right, hello. We're going to do the mathematical expressions quiz, which is our programming and algorithms, big idea three, topic three. And I'll just jump right into it. So, question number one is talking about this student is creating an algorithm to display the distance between numbers num1 and num2 on a number line. So, it's one dimensional. The following shows the distance for several different values. So basically, we're trying to compute these numbers here in a third column, which should be the distance between these two on the number line. We get the distance, it's equal to the difference between the two numbers, so we just subtract it. However, distances cannot be negative. There is no negative distances. No one's ever going to tell you, hey, yeah, it's just negative 2 hours from here. So distances cannot be negative. So we'll take an absolute value of the difference. I don't think we need to do anything more. So let's see which one of these would work. And you can just kind of test the algorithm with the values here and see if it works or some other sample values. Which of the following? Okay, so step one, add the num1 and num2. So right away, adding, nope, can't be that. It's a difference. You can't be adding them. Okay, part B here, choice B. Subtract them and store the result as a diff. Take separately. Yeah, that's it. That's all you got to do, really. Is just, yep. Let's see. Let's just check the other ones. Take the absolute. Nope, you don't take the absolute values first. That would be silly because if you think about it, if one of the numbers is on the negative side and one of them is on the positive side of the number line, when you take absolute values of them, they're both on the positive side, so the distance has changed. Take the absolute value. Nope. Again, so both of these options suggest to take absolute values before you subtract them. So the shortest one is the correct one. Option B for me. They might be a different one for you. So subtract the two numbers and take the absolute value. That's it. Question number two. Teacher has a goal of displaying the names of two students selected at random from a group of 30 students in a classroom. Any possible pair of students should be equally likely to be selected. Um, which of the following algorithms can be used to accomplish this teacher's goal? So we have 30 students, and we need to pick two students at random, but we need two different students. So right away, we need to think that, like, when you pick the first student, you need to adjust to pick randomly from the rest of the other 29 students so that you don't pick the same student twice. So let's see here. Assign each student, option A. Step one, assign each student a unique integer from 1 to 30. Step two, generate a random integer from 1 to 15. This ain't going to work because basically, yes, while this would make sure that you don't get the same student twice, it doesn't really generate two random students from the entire class. It just basically picks a random student from one half of the class and another random student from the other half of the class. So while they're never going to be the same student, they're not truly random from the entire class, two random students from the entire class. Let's see, part B, assign each student a unique identifier from 1 to 30, generate one random integer from 1 to 30, select that student and display the name, then generate another random integer from. So again, this would work, but the problem here is you might get the same student. There's a 1 in 30 chance, or 1 in 29 chance. So not that high, but that's still about 3% chance or so that you'll get the same student twice selected for both. So that can't be it because you don't want to allow for that possibility, even though it's a very small chance, 1 in 29. Step choice C. Uh, assign them numbers from 1 to 30, generate an odd, and then I can see a head generate an even. Yeah, that don't make sense because again, you're just picking. Yes, they're never going to be the same student picked twice, but you're still kind of like in the first one here, just slightly differently. You're only picking one student from one half of the classroom and the other student from the other half of the classroom. So that's not truly a random, choice of two students from anyone in the classroom. And that means that the last one must work, which is true because it picks one from the first 30. You assign that and display it, but then you give them a value 0, which is outside of the regular index values, and then the other ones are assigned new index values from 1 to 29. and then you pick a new random number from 1 to 29. So this should work because you basically pick one and you set them aside one way or another. This is a weird way to do it, but you just basically are removing them from the next selection, and then the next selection is from the remaining 29 students. All right. Question number three. Which of the following code segments can be used to interchange the values of the variables num1 and 2? So when you're interchanging values, it doesn't work like like you might think, like you swapping things with two hands, but with the computers, it just doesn't work like that. So um, let me see if I can draw this. So if I take number one and overwrite it with number two, that number one doesn't exist anymore. The only thing that exists is the value that was stored in number two. And then when you say number two equals to number one, well, it's really just the same as number two. So basically now both of them are just value number two. They didn't swap. So you have to, when you're swapping values in programming, which is actually something that happens pretty often for sorting, anytime you're sorting, well, not all of the sorting algorithms, but some sorting algorithms require to swap elements. And when you're swapping them, you have to have a temporary, like, or a side place. So what you do is you take one of the values, you put them aside, like right here, you take temp, and you take this num1, and you put it aside in temp. And then, well, no, this one's wrong because then it just says temp equals to num1. So that's, just, forget any of that. So num1 stays whatever num1 was, and num2 is num1. So both of them have whatever num1 was. So that's not right. But the concept of temp is still correct. And it looks like it's going to be C here because it's in the temp is basically brought back at the end to recover the original value. However, over here, we're putting the original value back in num1, so that's not correct either, because basically we say temp equals to whatever num1 was, and then number 2 equals to whatever num1 was. So now both temp and num2 and num1, all of them are equal to whatever num1 was, and then at the end, we're just reassigning the same value back to num1. So everything is num1 here, so that ain't it. And it is the last one here. So we're taking num1 and we put it aside into temp, okay? And then we say, well, okay, now we saved what num1 was. Now we're going to make num1 take the value of num2, and then num2 takes whatever temp has, which was the original value of num1, eventually basically recovering the original num1 value. So again, what's going on here is we have this temporary location that stores the value of num1, so that when num1 is overwritten here, so we get num1 has new value now, temp still holds the original value, and it can be recovered and put into num2. So option D in this case. And I'm sorry, I don't have a touchscreen, so it's kind of hard to use the pen with this, with the mouse, but let's go and move on. So for that question, it was option D. Question number 4. We have words stored in the variables, word 1, 2, and 3. The values of the variables are to be updated as shown in the following table. So we have originals and then after updating. So we need to kind of figure out what happens here. So word 1, word 2, word 3. So this is really probably best if you just kind of trace it out and figure out which one would work. So which of these would be used to update? So, I mean, we can kind of work through it. So let's see. So word 2 stays the same. So first of all, we don't even have to consider word 2 because that one stays the same. And all we're doing is swapping. So I think in this case, it's probably best to just kind of figure out what is going on here. Um, so we're just swapping these two. So this is quicker than actually trying to run through each algorithm, see if it does what this shows. If we just kind of look at it a little bit, we can recognize, well, hey, word 2 is unchanged. So we can just leave it unchanged. So anything that talks about word 2, we can just forget that. So right away, I'm just going to assume that these two are wrong. Yeah. Nothing happens to word 2. Let's not touch it. So really all we're trying to do is just swap these. And if you remember from just earlier example, what we're going to do is take one of them, put it aside, and then take that value and overwrite it. So this one is not right because what we're doing is we're saving word 1 in temp, but then we're also putting it in word 3, which doesn't really help us because now word 3 is equal to word 1, temp is equal to word 1. So this last command is useless because word 1 is still word 1. So everything is just word 1. So that ain't right. So let's see, which means B has to be the answer, but let's just verify. So we're taking word 1 and putting it inside. So temp is word 1. And then we overwrite word 1 with word 3, which is, so temp is now xylophone. Word 1 becomes zebra. And then word 3 becomes xylophone. So it's this one. So again, just don't try to memorize it, just kind of recognize what's happening. We're taking one of them, in this case, word 1, we're putting it aside for a moment, and then we're overwriting it. That's why we had to put it aside. So word 1 now doesn't have the original value. It's whatever word 3 is, but then we basically overwrite word 3 with the original value of word 1, effectively swapping word 3 and word 1. All right, and let's um, oops, let me get rid of this. And let's see if we can get through this quickly here. We have this code segment, x is equal to 23, or x takes value of 23. Operator mod. So I hope you look this up or watch the videos that explain it. Mod operator is a remainder operator. You don't really deal with remainders very often in your regular math classes, I bet, since middle school. But in coding, mod operator comes up quite often. It can be, there's different symbols for it. The percent symbol is a mathematical symbol for it, or mod for modulus. So it's modulus or mod short for modulus, or the percent symbol as in like the remainder of the division. The division symbol, of course, is just like if you do 7 divided by 3, well, that's 2.5, or 2 with the remainder of 1. So if we put the percent symbol, the result is just a remainder. So 7 mod 3, or like you might see mod or modulus. So 7 mod 3 is 1. It's the remainder of that division. So let's see. Z is x mod y. So which of the following initial values of the variable y would result with the variable z being set to 2? So x is 23. So basically what we're looking for is any number that would give us a remainder of 2 when we divide 23 by it. That's it. So just a little bit of math here. So if x is 23, 23 divided by 1 is just 23, no remainder. 23 divided by 2, anything divided by 2 can only give you a remainder of 1. So it can't be that one. It's going to be 3. So 23 divided by 3 is going to be 21 is 3 times 7. So it's 23 mod 3 is 7 with the remainder of 2. So the answer here is C, 3. And finally, last question. There's a lot of assignments here. So I'm going to work this backwards. I'm going to see what is the question asking. What is displayed as a result of executing the code segment? So basically, we're just looking to see what are these 4 things going to say in order A, B, C, D. So I'm going to start from A. It's going to display A first, and I'm going to work it backwards. So A is x plus 1. What is x? Well, x is working again backwards, is 20. So 20 plus 1 is 21. So I'm going to look for, okay, so it ain't A. Okay, so it ain't A. Okay. What else we have? So next one is B. And let me see which ones are different. Okay, so So they all have two the same. Okay, so let's just go in order. So let's look at the next number. So it's 21 is the first one. And then b, what is b? B is equals to x plus b. Well, working upward, backwards, x is 20, b is 20. So we say 20 plus 20 is 40. And this is okay that we have b on both sides because the order of operations is to do whatever is on the right hand side first and assign it here. So we have 20 plus 20 is 40, and now b is 40. Um, so it can be C or D. So it's not this one and not this one. Right? It wasn't 10 and it wasn't 30. So now I'm going to skip to the last number because both of them have 30 for the third number. So that won't help me. So I'm just going to look at what D is. Is it 40 or 50? So just a little bit of test taking strategy. Look ahead. So what is D? D is equal to C plus half of D. So what was D before this? It was 40. So 40 divided by 2 is 20. C is 30. So 30 plus half of 40, that's 50. Meaning the answer is D. Thank you all very much.